Hi there. Welcome to today's episode of my 30-day journey of fractions, where I attempt to teach you how to solve all fractions related problems that are essentially and specially picked from common entrance pass questions, GSSE, SSE, and even SAT, which is Standard Aptitude Test. Now, before we delve into today's lesson, please, as usual, be kind and generous enough to click on the subscription buttons below this video to get notified of more educative and academic lessons like this, and of course of the subsequent episode after this. See you in a bit. So in today's lesson, our focus is going to be on application of mathematics to solve real life challenges in fractions. So let's see our first questions for today. So the first question for today says, after reading 255 pages of a novel, there still remains 1/4 of the book to be read. How many pages are there in the book? Again, after reading 255 pages of a novel, there still remains 1/4 of the book to be read. How many pages are there in the book? Okay, so to tackle questions like this, word problems like this, first of all, we have to consider some factors, the factors of numbers and fractions. So in the first sentence, in the first part of the sentence, it says, he has read after reading 255 pages. So we are going to say, our first arrow will be that after reading 255 pages of a novel, that means a novel means 1 whole. In fractions, we have to understand that a whole means 1. So a novel means 1 whole. So we'll say, whole book. Whole book is equals to 1. And then, so after reading these 255 pages, so we are going to say pages read. Pages read out of the 1 whole book is 255, but we don't know the total pages that is unread. So they said there still remains 1/4 of the book. So fraction, we are going to label this as fractions of the page unread. Fraction unread. Fraction unread. Now I need you to pay attention to this part of the interpretation. This is the numbers of pages read, and then this is the fraction unread, fractions of the book unread, which is 1/4. Meaning that if 1/4 of the book is unread, definitely the numbers of pages read will be 3/4. So that means this part that is read is, the fraction of it is 3/4. You need to understand that this is the page number that is read, and then this is the fraction that is equivalent to this page that is read. So this is a fraction of the book that is unread, that is not read. 1/4 of the book is not read. That means the total book is 4/4. So if 1 out of 4 is unread, that means 3/4 is read. And this 3/4 is the fractions of the book that is read, which is equivalent to this 255. So let's go on to the main questions of the lesson. It says, how many pages are there in the book? Now, for us to know how many pages are there in the book, first of all, we have to know pages read and fractions of pages read, which we have find out here. Now, so we now know that the pages read is 255. Then 3/4 is equivalent to the fractions of the pages that is read. So if 3/4 is the pages read, this 3 means 3 out of 4. So the 3 out of the 4 and the 3 out of 4 of the pages of the total pages is 255. That means the total pages will be what? 4. Will be 4/4. So to find pages, how many pages are there in the book? To find pages that are in the book, which is the total pages, we are simply just going to use what we have to find what we don't have. We have the numbers of the pages read, and then we have the fractions of the pages what that is read. Okay, so we are just going to flip over these fractions by writing 4/3, because 4 represents the total pages, and then these 3 represent the pages that is read. So multiply by the numbers of the pages read. So we have 4/3 times 2/3, times 255 over 1. Now what we now need to do is to consider what is divisible, common factor of what can be divided in the numerator and then in the denominator. So 3 in 3, here goes, we have 1. 3 can't divide 2, so we pair 2 and 5 together, and that makes 25. So 3 in 25, that is 8, because 3 times 8 will give you 24. And then if you take away 24 from 25, you are going to be left with 1. So we are going to pair this remnant of 1 with 5, making it 15. And then we divide further by saying how many 3 goes in 15, and that will be what? 5. So we have 4 times 85 left in the numerator. So multiplying 4 by 85. Now I won't advise you use your calculator, but if you can calculate this mentally, you could as well employ doing it manually, which is 4 times 5, and that will give you 20. So you put 0 at the end, and then you imagine that you've raised 2 here, and then 4 times 8, and that will give you 32. So 32 plus 2, and that will give you what? 34. So there are 340 pages in the book, and that is that about question number 1. So let's move on to question number 2. Okay, so question number 2 for today says, a housewife spends 3/7 of our money, 3/7 of our money, we are dealing with money in this regard, to buy yams, and then that means you're also dealing with items, and half of the remainder to buy rice. What fraction of our money is left? Please take note of this, what fraction of our money. We are being asked what part of our money is left. We are being asked what fraction of our money is left. So that means we are going to start with the principle of infraction, or a fraction is part of a whole, meaning that an entire thing's in fractions principle or in fractions problem is 1. So a whole, the whole money, so I'm going to say the whole money, the whole money is equals to 1 whole. And then so the housewife spends 3/7 of her money, which the whole money is 1, and then she spent 3/7 out of this whole to buy yam. So I'm going to take an hour and write yams. What she spent on yam? She spent 3/7 on yam. 3/7 of what? Of her whole money. And we said her whole money is what? 1. So she spent 3/7 on yams out of her whole money. That means if she spent 3/7, please don't forget what I did earlier. If she spent 3/7, this means 3 out of 7. So the entire money is actually will be 7/7. So if she spent 3/7 of her money on yam, that is 3 out of 7. So if something is out of something, 3 out of 7 will be left with 4. So the remaining, or the remnant, will be, I'm going to open a bracket, so I'm going to say remnant, or the remnant will be 4/7, because she has spent 3 out of 7 of our money on yams. Our whole money is 1, which is equivalent to 7/7. So if our total money is 7/7, which is equivalent to 1, and she spent 3 out of that 7, the remnant will be what? 4/7. So she has spent 3/7 on yam. So let's move on with the question. And then it says, and half of the remainder, this remainder, half of the remainder to buy rice. So I'm going to write rice. So since we say half of the remainder, half of the remainder, we are going to translate this off to become times. Half of the remainder, what is that remainder? The remainder isn't 3/7. Half of the remainder, which is 4/7, because she spent 3 out of 7 on yam, that means the remainder is what? 4/7. So half of the remainder, that is half of 4/7 on rice, and we are going to evaluate this to find out the value or the fractions of money she spent on rice. So now let's find what can divide common factor. 2 certainly goes in 2, we have 1. 2 certainly goes in 4, and then we have 2. So at the numerator we have 1 times 2, which is 2 over, and then at the denominator we have 1 times 7, which is 2/7. So she spends 2/7 on rice. So let's proceed on with the question, and then the next question, or the main part of the question, then says what fraction of our money is left? What fraction is left? So to find what fraction is left, we have to find the total fractions of the money spent. we have to find the total fractions of the money spent. So we are going to say total spent. Total spent is she spent 3/7 on yam, 3/7 plus, and then she spent 2/7 on rice, which is 2/7. So in total, she spent 5/7 altogether. And if we know the total amount spent, so to find the fractions of money that's left for her, so we say fraction of our money left will then be, now we know that the total money is 1 whole, which is the same thing as 7/7. So I'm going to bring the 7/7 into picture because we also have 7 here. But then we could use 1, we could say, since the whole money is 1, we'll say 1 whole minus the entire money is 1 whole. Take away the total spent, which is 5/7. And then we could rewrite this to become, we are going to rationalize this one to become the denominator by making the numerator 7 and then making the denominator what? 7 to make it 1 whole, which is what we've written here before. So 7/7, because in literal sense, 7/7 is the same thing as 1. So rationalizing is so that we can have a common word denominator. So 7/7 minus 5/7. And that will give us what? 7 minus 5, that will give you 2. And then 7, because this is their common denominator, we're just going to bring out this 7. So the fraction of our money left is 2/7. So that is that about question number 2. Let's move on fast to question number 3. Okay, so question number 3. After spending 2/5 of my money, after spending 2/5 of our money rather, after spending 2/5 of her money, of his money. After spending 2/5 of his money, Alex was left with 36 pounds. What was the original amount? This is so straightforward. But again, let's read again to digest the question. After spending 2/5 of his money, Alex was left with 36 pounds. What was the original money? So, just like we've been doing, we are going to identify the whole money. Since this is about money as well, the whole money to be 1, because we say a fraction is part of a whole, and a whole means 1. So after spending 2/5 of his money, that means 2/5 of this amount, Alex was left with 36 pounds. So if she spent 2/5, we'll say fraction spent. We're going to identify this 2/5 as fraction spent because that's literally what it is. It said after spending 2/5. So fraction spent, don't forget there's a difference between fraction spent and the amount spent. So this is fraction spent. So fraction spent is 2/5. So if she spent 2/5 out of this 1, so if 1 here is the entire money, that means 1/1 is the same thing as 5/5, which is the same entire money. So 1 whole is the entire money, and then 5/5 represents what? 1. Just to rationalize it or give it a common factor with the fraction spent. So the fraction spent is 2/5. That means the remainder, if she spent 2/5 of her money, that is 2 out of this 5. 2 out of the 5. Then the remainder will be, I hope you can be able to guess it. The remainder will be 3/5 because she spent 2 out of 5 of her entire money. That means the remainder will be 3/5. So they now said Alex was left with 36 pounds. So the remainder, so they said he was left with 36 pounds. So amount left. This is not, now this time around, this is not fraction left. It is not amount left because this is actual quantity of money. So amount left is 36 pounds. Now if amount left is 36 pounds, what is the fraction left? Fraction left is 3/5. So that means this 36 pounds is in fraction is represented by 3/5. That means 3/5 is a fraction of the total amount spent, which is 36 pounds. So 36 pounds represent 3/5, and then 3/5 represents 36 pounds. Now knowing what represents what, so we can use what we have to solve what we don't have. We have the amount of money left, and then we have the fraction of money left. So then we can be able to now find what was the original amount from this. So the original amount is this 5. So we are going to say original amount is now equals to this 5. We are going to inverse this 5/3 because you are looking for original amount, and then this 5 represents the original amount. Don't forget what we did here as well. So we are going to say 5/3. I'm flipping, I'm inverting this quantity. So we are using these two that we have to get what we don't have. So 5/3 times the amount left. So the fraction of money left inverted, then times the quantity of money left. So 5/3 times 36 pounds over 1. So now let's look for what can divide in their common factor. 3 goes in 3, we have 1, and then 3 in 36. You could take it one by one if you don't know how to divide mentally. So 3 in 3 gives you 1, and then 3 in 6 will give you what? 2. So that means you have 12 pounds in the right hand side of the expression. So 5 times 12, we are going to have what? 60. So the original amount is 60 pounds. So, and that is that about question number 3. Let's go to question number 4. Okay, so question number 4 for today is a little bit different from the ones we've been solving so far. This is more or less like a question on proportion, which explains that as a part of the quantity is increasing, so the variable also what increases. So let's delve into the lesson straight away and interpret the question. So it says, if 1 centimeter on a map represents 37.5 kilometers on land, what does a length of 2/5 centimeter on the map represent? Again, if 1 centimeter on the map represents 37.5 kilometers on land, that means on the land, the real measurement is that 1 centimeter represents 37.5 kilometers. In the map, it is 1 centimeter, but on real land, it is 37.5 kilometers. So what does the length of 2/5 centimeters on the map represent? Okay, so let's interpret that as an equation. So 1 centimeter represents 37.5 kilometers. We are just going to write 1 centimeter equals to 37.5 kilometers. Okay, so that's represent for you. 1 centimeter represents this, so that means this is equals to this. Okay, and then the next question or the next part of the sentence is, what does a length of 2/5 centimeters? So I'm just going to write 2/5 centimeters. What does it represent on the map? Equals to what? Put a question mark. So now we've learned in some previous lessons that if something is in a multiplying aspect, or if something is having a multiplier effect, that means as a part of an equation is increasing, the other part is increasing in multiplier effect. That means that if 1 centimeter is 37.5 kilometers, that means 2 centimeters will be in 2 places of this, will be 2 places of this, or 2 times of this. And then 3 centimeters will be 3 times of this, and then 4 centimeters will be 4 times of this. So that's what I mean by multiplier effect. So one quantity having a multiplier effect on the other as they are increasing. So if 1 centimeter represents this, that means 2/5 centimeters represents 2/5 centimeters times 37.5 kilometers. Simple as that. But then this isn't our answer. We have to evaluate this. So to evaluate this, you find what can divide in the numerator and denominator, which is 37.5. Don't forget that we could rationalize this to be over 1. So we say, now this is a decimal number. So actually we can say divide because it has 5 at the end. That means 5 can divide it. So 5 in 37. Now if you can calculate that mentally, 5 times 5 gives you 25, 6 will give you 30, and 7 will give you 35. But 8 will give you 40. So we are not going to use 8 because 40 is above 37. So we are coming down to 7. So 5 in 37, we are going to say 7 because 5 times 7 is 35. Now if you take away 35 from 37, you will be left with 2. So that 2, now we have a decimal point before this number. So I'm going to write point A also after the 7, and I'm going to put the T2. I'm going to pair this 2 with this 5 to make it 25. So 5 in 25, and that will give us what? 5. So 5 in this number now is 7.5. Then 5 will cross out itself. Now nothing left to divide, so we multiply the numerators, which is 2 times 7.5. So 2 times 7.5. In the denominator, we have just 1, so there is no need or no point writing it. So 2 times 7.5 means 7.5 in 2 places, because 7 in 2 places will give you 14. So 7.5 in 2 places will certainly will give you what? 15. So what's our unit of measurement? Kilometer. So 15 kilometer. That means that on the land, on the map, we have on the map the measurement is 2/5 centimeter. While on the land it is 15 kilometers. So 2/5 centimeter represents 15 kilometers on the land. And that is that about question number 4. let's move on to the final question for today, which is question number 5. Now, question number 5, which is the final question for today. A lorry tank was 4/6 full of fuel when the gauge indicated 72 liters. What was the full tank? Again, a lorry tank was 4/6 full of fuel when the gauge indicated 72 liters. What was the full tank? So to interpret this, 4/6 is a gauge fraction. Okay, so we say gauge fraction. Gauge fraction is 4/6, and then the question says 4/6 full of fuel when the gauge indicated 72 liters. That means the 4/6 gauge fraction represented 72 liters. So that means the 4/6 is a fraction of the full tank, and then 72 liters is the amount of the tank, or the amount of the tank when it was 4/6 full. So that means this 4/6 represented 72 liters. So the main question now says, what was the full tank? So this is the gauge fraction present gauge fraction. So we then say full tank. Full tank will then be 6/6. So if full tank will then be 6/6, that means to find out the full tank, the amount of full tank, we are going to use this 6 denominator. We are going to flip it over invert, because this 6 in actual sense represents the full tank. As I said, 4/6, and that means 4 out of 6. So 4 out of the 6 is 72 liters. So that means this 6 is the full tank, because they say out of something. So this 4 is part of this 6, and this 6 is the whole tank, so which is what we want to look for now. So we are going to invert the fraction using what we have to find what we don't have. What we have is the fraction of the current gauge, and then the amount of the current gauge, and then we know that the full tank is 6, so over 4. That will be inverted and then multiplied by the amount of the current gauge, so which is 72 liters. Now we find what can divide as common factor. So 4 can go in 72, of course, and then 4 can go in 4 and itself. So we say 4 in 4, that will give us 1. And then 4, if you can divide it mentally at a whole, you just say 4 in 7, and that will give you 1, remainder 3, because 4 times 1 is 4. If you take away 4 from 7, you'll be left with 3. So that will be 3. If I pair the 3 and 2 together, that makes it 32. So 4 in 32, that will give you what? 8. That will give you 8. Okay, so now we are left with 6 in the numerator here times 18 in the numerator as well. So 6 times 18. So now you can simplify this, or you can do this. You can evaluate this one by one by starting from the unit. So 6 times 8. 6 times 8, and that will give you 48. So you're going to write 8, and then you keep 4 above 1. And then 6 times 1, and that will give you 6. So 6 plus 4. 6 times 1, 6. 6 plus this 4 that we raise up here, and that will be 10. So we have 108 liters. So the full tank is 108 liters, which 4/6 is part of. So, and that is that for today's lesson. Please don't forget to kindly and generously click on the subscription button below this video to get notified of more entertaining videos, educative videos, and then academic videos like this, and of course of the subsequent lesson after this. And mind you, for this particular lesson of application of mathematics to real life word problem or real life challenges, we are going to be having 3 episodes of it. Okay, so see you in the next lesson. Thank you.